I'm Alex with the Biogen Virtual Community Lab, and I am bringing you a sort of different type of video today. So hopefully you saw the video about making lava lamps and you all got a chance to make your own lava lamp. So today we're gonna talk a little bit more about the science behind it. So this is sort of an explained video to talk about what's going on inside your lava lamps and go a little bit deeper into it in case you were curious or you had questions about what was going on. So I'm gonna release a couple of videos about a couple different topics with our lava lamp, but this first one, we're gonna talk about hydrophobic and hydrophilic solutions and how that sort of manifests in our lava lamp. So we touched on that in our lava lamp making video, but I want to go a little bit more into it and explain a little bit more about what's happening on a molecular level. So you see that I have my lava lamp here. It's done reacting. So now we're back to just our blue water and our oil on top of it. And you see that there's still this really clear separation between the oil and the water. And we talked about how that is because water is hydrophilic. And we talked about how that meant that hydro means water and philic means loving. So water is water loving, and there's other types of hydrophilic molecules, but we're going to look at water because it's a pretty easy one to sort of grasp this concept. So we know that the water molecule is H2O, which means that it's made up of one oxygen atom and two hydrogen atoms. So what happens with this molecule is that we know that there are electrons. And so in this molecule, those electrons shift up towards the oxygen. So it makes it a little slightly negative. And since it pulls away from these hydrogens, they become slightly positive. So you end up with this electron cloud where all your electrons are up here with the water. And there aren't very many at the hydrogens. So this is sort of what's going on with your water molecule. You end up with all this negative charge up here and this positive charge over here. So what happens is when you get multiple water molecules together, so let's see what would happen if we added maybe another water molecule. It has that same phenomenon happening, right? So it has this slightly negative and slightly positive. So we know that negatives and positives attract, right? Just like a magnet. So the south end and the north end of the magnet will attract to each other and form a bond. The same exact thing happens. So the negative oxygen will form a bond with this water molecule's positive hydrogen. And then the same thing will happen here. And if we had more molecules, it would keep happening. So these are called hydrogen bonds. And it's what happens when you put this type of molecule all together. So these molecules get really tightly bound to each other, just like a magnet. They're very attracted to each other, and those bonds are hard to break. So the water is really closely knit. All these molecules are bound together. It's really happy with itself. So it's hydrophilic. So when we look at hydrophobic, we know hydro means water. Phobic is fears. So these are things that don't like water. They're afraid of water. So that's things like oil. And so the difference is you don't see the same type of molecule. So oil is a very long chain of carbons and hydrogens. So I'll draw this. So you have carbon, and then you have some hydrogens. So this is just an example. A lot of oils are chains that are much longer than this one is. I just wanted to give you sort of a picture of what an oil molecule would look like. So you end up with this long chain of carbon and hydrogens. And what happens with its electron cloud is it doesn't have this pull like the water molecule does. So all the carbons and the hydrogens share electrons evenly. So there is no positive and negative end of this molecule. It's all pretty neutral because it's all dispersed amongst the entire molecule. So for simplification, I'm gonna draw it like this. So if this is our molecule and we end up having a lot of those, what happens is they like to line up and sort of nestle together. And they are also bound, just like these are bound. But instead of hydrogen forces, which is what's causing this bonding, they have something called London dispersion forces. And what those are basically just when you have these long chains that are stacked on top of each other, as they get close to each other, they kind of like each other, they like hanging out together. But these bonds are not very strong, so they're pretty easy to break apart. They'll sort of float on their own willy-nilly relatively easily, whereas these bonds are extremely strong. So when you put these two types of molecules together, these guys stay really closely bound together, and they don't want any part of these guys. And these guys don't really understand what this negative and positive stuff's all about. They don't have any attraction to that. So they just prefer to stay with themselves away from these. So that's sort of what's happening when you have these hydrophobic and hydrophilic solutions coming in contact with each other. You can tell they're very different types of molecules, and that's the reason why they don't want to sort of combine together and be in harmony, right? They want to stay separated, just like in our lava lamp. So that's what's happening in our lava lamp, and that's why you see that clear, distinct line between the water and the oil. So make sure you comment below if you have any more questions about any of this or about any of the other science. I'm going to post another video talking about the acid-base reaction, so check out that as well, and let me know what you think. Have a great day, everyone. Bye.